we are going to move to our panel discussion of the day. And this panel discussion today will focus primarily on green hydrogen technologies and applications. Yesterday, our panel discussion was focused more on the commercial aspects, and today we have an amazing lineup of technical experts and R&D experts who will gather around Dr. Wijaren from AHP, whom you've heard from yesterday during the keynote. And for those of you who were not there yesterday, so I'll read you a brief introduction of Dr. Wijaren. Excuse me, I'll go back. As I mentioned yesterday, the hydrogen space is really interesting because it's at the crossroads of professionals from the renewables industry and from the solar industry, which we are supporting, but also we have a lot of professionals coming from the oil and gas industry. And this is specifically the case of our moderator today. So as you can see, he's had a long experience with some of the big names of the oil and gas space, Eni, Total, Technip. And on top of this, he's been focusing his career on disruptive engineering innovations. So this is really like the perfect angle to address the topic of green hydrogen in Africa. And so without further ado, Dr. Wijaren, I welcome you to today's presentation. I'm going to give you the co-hosting rights now, and I will let you introduce your panelists today.
Thank you very much, John. Good opportunity again to be among the panelists. And can I say good morning or good afternoon or good evening to our listeners, wherever you are connected from. It's my pleasure to really be able to moderate these sections. I can also say joining me on this very panel section are very, very experienced, what I may call specialists. So it's a great delight. And also to notice that these are specialists that have been in the industry for decades, not just, they have very, very good experience in the industry in terms of disruptive engineering, because what Africa needs today is a disruptive engineering to really be able to pave way for hydrogen. It has been a very, very I'll say long journey for Africa, but it's a time now for Africa to really be able to rise up and take the challenge. And thanks to Matt for really opening the initial section with so many information to enlighten the people, Africans, on the opportunities, what I may call the low-hanging fruits that we can really latch on at this moment while we wait for the export opportunities. Without more ado, join me in welcoming our panelists as I introduce them to these discussions. Let me start by welcoming Dr. Chen Zhu. That's, well, I wouldn't want to really say much about each of the panelists. They will speak for themselves. Dr. Chen Zhu, you're welcome to these panel discussions. Maybe you can introduce yourself and then say a little bit about your company and also what you do, as a specialist.
Okay, thank you very much. So, can you hear my voice?
Yes.
Okay, great. So this is Chen Zhu from LONGi Hydrogen. So really happy to have the chance to share some my understanding regarding the hydrogen and also by honest, previously I have more than around 10 years R&D research on solar energy, and recently I joined the hydrogen energy part from LONGi to continue my R&D research. So and you know that LONGi is well known as the world largest solar wafer and panel suppliers, and based on our strategy analysis, we think that the renewable energy plus hydrogen will becomes very important solutions to achieve zero emission. So we established the LONGi Hydrogen in last year, means 2021. So currently we focus on the alkaline water electrolysis equipment. So our target is become a world lead water electrolysis equipment supplier. So in less than 1 year, we already set up around 500 megawatt capacity, and by end of this year, we will achieve around 1.5 gigawatt. So always believe that the best product comes from the best design. So we are focused on R&D researching, and we will bring our best, do our best to bring our customer the best product. Yeah, thank you very much.
Okay, thank you very much, Matt. Just to reassure our listeners again, it's a good opportunity to have these experts joining us today. And I also want to encourage you, if you have any question, feel free to put it on the chat box, and we'll be able to, as much as time permits us, handle those questions as they come in. I believe it's going to be a good time for us to look at these opportunities in hydrogen in Africa. Okay, next I would like to also to introduce the next panelist that will be joining us today to look at this important subject, and that's John George Wagerfield. I hope I pronounced his name correctly. So he will introduce himself, and he will also tell us a little bit about what he does as an individual and what his company also does as well. Thank you, and you're welcome, John George.
Thank you for the introduction, and I'm very happy to participate in this discussion. So my name is Jan-Georg Wagenfeld, German name. I have been working for the technology team in Master Clean Energy, and Master Clean Energy is a large renewable energy developer, mainly in the past for solar and wind. We are in more than 40 countries and are involved in projects with a cross capacity of 14 gigawatt. So in the past years, we have then been seeing the transition to green hydrogen and have started to study the potential. We have one e-fuel project we are currently developing in Abu Dhabi, where we are planning to demonstrate green hydrogen to e-fuel to sustainable aviation fuel. It's in the development, and then we are also involved in large-scale green hydrogen projects globally now. So I'm looking forward to the discussion.
Thank you very much, Jan. Next on the panelists that will be joining me today to handle this section, I would also like to introduce our next panelists, and I would like to introduce Matthew Sklinger. I hope I also pronounced the name correctly. Please, Matthew, or Matthias, can you please introduce yourself and tell us a little bit about your company and what you also do in the hydrogen space? Thank you.
Thank you, Dr. Innocent. So my name is Matthias Schlegel, German name, horrible to pronounce, I understand. I guess you only see my background and not myself, which is a bit sad. I'll start with the introduction anyways and then try and get my face on the screen. So yeah, I've spent the last 10 years in hydrogen. My background is I'm an engineer, and as you can see, I've started in engineering of hydrogen, and then as hydrogen became more and more interesting on a global scale, project development, my focus has shifted to helping investors and project developers getting commercial projects on the ground. So I'm not a researcher. I'm more focused in actually tangible projects going forward. Just have to say, I'm happy to hear that I've worked with two of Jan-Georg's employers already, and we've never met. So my first project was in CSP at Masta, Shams 1, and my second one was with Fresnel, Puerto Dorado 2. So I'm happy that we sit on a panel together, and I maybe say something about Fichtner. Fichtner is Germany's largest independent engineering and consulting company. We have 1,800 employees worldwide. And we've been doing projects in Africa for around 45 years now, have done 500 projects on the continent. And we have a long-standing history with hydrogen, about 3 decades. And today I'd love to discuss how we can get the hydrogen experience that we already have on the ground in Africa.
Good. Thank you very much, Matthias. Good to hear that you've actually been involved in the hydrogen in Africa. I think that would be, we would like to really share from your experience as well. Okay, let me now start with Matthias, if you don't mind, because you're looking at the African sector, for instance, when we look at the technology environment, one thing that is a major driver is, standards. I've been in the industry for decades now. Standard is what controls what we design and how we design things. Matthias, if you don't mind, then can you share with us how has it really been in terms of standard when it comes to hydrogen, or let's say the green space generally? I have personally struggled to actually pin down a standard in terms of what I would call a global harmonized standard that is being worked to. So you see each company is working their own, what I'm calling their own silos on the standard. Some clients work in their own silos on the standard, but a unified global standard is something I actually struggle to find. How really have your company cope with that kind of being able to juggle your client standard, your own standard, when there's no global standard that actually drives the whole system?
Yeah, I mean, that's not only hydrogen specific. That's if you work for a lot of clients and a lot of countries, it's always an issue. I've personally worked in the aerospace industry, in the power plant industry, in renewables. You are absolutely right in pointing out there's always something to adapt to. The good thing is physics and technology will stay physics and technology regardless of the country, regardless of the client you have. So that's as an engineer, you always have to learn. And I think for us, it's always interesting to be in other countries and to learn about the standards that they have. And it's not just internationally. If you look at, for example, I think last October, we visited a hydrogen fueling station in Italy. And it's probably 3 times as big as it would be in Germany, simply because the standards are different, because you have to have huge safety distances. You have walls in between. The thing looked like a military installation. And here, just in my hometown, there's one just right on the airport, looks like a normal gas station. So you're right, there's things to learn. Luckily, on the production side, hydrogen is something that has been around in quite a bit, as you're fully aware, coming from the oil and gas industry. So I think on the production side, there's quite a bit of established standards technically. Everything consumer related, I think we have a way to go there.
All right, thank you very much. I wanted to know if I'm the only one struggling, and I know some of the guys connected online will also be struggling in the area of standardization of equipment for the hydrogen space. Okay, let me now move then to Dr. Chen Zhu, if you don't mind. Can you share with us how has it been on the Asia side, let's say in China or within the Asia regions where you normally deploy equipment? Can you share your experience? How has standardization been in terms of the green technology space, or let me just specifically go to the hydrogen space, manufacturing these equipment? How has it actually, have you been able to juggle between these standards and aligning in the equipment designs?
Yeah, so in fact, according to my understanding, in fact, in China, even in Asia, so the hydrogen energy also is in the early stage. So the standard is also under developing. So it's not only based on the equipment itself, it's also based on the grid, the safety and the environment. So different kinds of different countries, and also have the different specifications for both of all the grid equipment, the safety, all the things. So from country to country, so you find that it's totally sometimes you will find that it's totally different. So we are also collecting all the kinds of the center internally, and to check is there any chance to combine some together, or to find the common things, and to try to meet most of the different requests from our different customers from different countries, different areas. Yeah.
Thank you very much. I think it's aligning that the issue of standard is a global issue, not really a localized issue. Then, if you don't mind, Jan George, let me come to you then. What will be your advice to Africans, for instance, some technological companies in Africa who are thinking, okay, I want to get involved in this technological space, but they are a bit scared that, oh, I don't have a standard to guide me. I don't know, how do I juggle between all of these? What would be your advice to such a companies? Maybe they are connected now.
I mean, again, as Matthias mentioned, it really depends on, do you go to the production side or the consumption side with refueling stations, for example. I mean, usually if you have already a chemical industry, I would rely on the know-how, and you're probably following AFSIA standards or European standard for, let's say, the balance of plant and all the piping. So this already gives some guidance what you could follow. And then in the end, there will be a period where the developers and the OEM providers have to trailblaze a little bit sensible standards. I think we are struggling exactly with the example Matthias brought up, that how big is the safety distance for example, refueling stations. You have to make it sensible. And I think there will be definitely a period where it's up to all the parties involved in this space to come up with sensible standards, lending from, let's say, I already know how from the chemical industry, the oil and gas industry, but again, finding a workable solution. And this will be an iterative process with all the parties involved.
Thank you very much, Jean-Georges. Let me now go to the next aspect of a very, very challenging aspect of the technology, which is cost. At the moment, I know it's a global issue, but because the main driver of the cost, I remember listening to one of the speakers yesterday who mentioned 80% of the cost of hydrogen production, actually in terms of the capex, comes from the technology, aspect of the production. So what that means is that the main driver of the cost is still technology. But if you don't mind, again, coming to you, Matthias, having experienced a little bit about the African side of things. Of course, Africa is unique in a way because every maybe sub component of the technology itself is going to be imported. So that even add to the costs, apart from the fact that it's already expensive from the main manufacturing site. So let me now listen to you on this. How do you think we could be able to really manage this aspect, for instance, without having more cost impact? It's a challenging question, I know, because we are trying to now reduce costs. Cost is already high on its own, but how really do you think, or let me just put it in a more simpler way, for instance, a technology developed locally, of course, will remove that cost. But again, we're not yet there. So would it be okay? Do we focus on technology at this moment that will look at the localized aspect where we remove a little bit of the import aspect? Of course, that can be, an aspect that any of the companies listening to us now want to really get involved in. Is okay, let's focus on the local side where we don't need to import some of these equipment. Of course, some will be imported, but not all the equipment. So what would be your advice then in terms of how do you see the options of really removing the impact of cost with importing of this equipment, considering that technology already is having a huge impact in terms of the cost? Let me just hear your view on that, please. You're muted, please, Matthias.
Sorry, thank you. I think there's two aspects to this. The one is, if you look at the overall costs of hydrogen, how are they composed? Part is, as you said, exactly the electrolysis capex, and the other is energy. And it depends on the setting you're in. If you have, for example, like in many regions in Africa, a great combination of wind and solar that gives you many full load hours throughout the year, or you have hydropower, or you have geothermal. I think Africa has many parts of the continent with renewable energy sources that are very well suited for hydrogen production. Why? Because with every full load hour that you have, the impact of capital costs goes down and down, right? If you just have solar, you get to a usage rate of your plant of maybe 35%. But if you have a good combination of solar and wind, you get to a higher usage rate. With hydro, geothermal, even higher and higher. And this means your fixed cost distributes over a higher production part. And this means the actual share of the components, the new technology that you're talking about, goes down and down and down for every kilogram. So I think Africa actually has a competitive advantage there just because of the type of natural resources that are there. And the other thing is, what's important to remember when people talk about electrolysis, they always talk about the cost of the electrolysis package itself. But what's not to be forgotten is it's an entire plant. You coming from the oil and gas industry, again, you know it, right? There's piping and valves involved. There's pressure tanks involved. There's a lot of civil involved as well, which is not to be forgotten. And that's not even speaking about everything that you need to construct to actually get a useful infrastructure. I mean, if we're talking about going to hydrogen, if we are talking about actually reaching net zero, this means we are going to change our entire world. This is not just the production plant. And there's a lot of local value added that's possible there. So I think, yes, there's parts that are to be imported, but I think you can actually generate quite a bit of local value added in the entire value chain, going from the electrolysis up onto a harbor.
Thank you very much, Matthias. I think you just mentioned something that struck my mind now, and that is the fact that the cost is not just based on the equipment alone, but also on the power or the energy, to power the whole system, of which Africa has an advantage here in terms of the sun, the wind, and also the hydro in some certain locations. That's good. So, John, let me look at it from another perspective again with you then. I know one area that I know a lot of Africans worry about is what we call the energy balance in terms of, they tell us we're struggling right now with power. And then we're not talking of taking from that same power to now go and power the electrolysis system for hydrogen. But again, I think sometimes they forget that hydrogen is only a carrier. You're not actually you're like preserving that power in a way. So it could be used, like, for instance, for a backup system or for the power, which means you are preserving your power to reuse it later, not like you're actually throwing it away. So what then will you let's look at your view in that area. How really can we maintain kind of an energy balance in a way, not really, using the energy to the extent that even the common, African will no longer have an energy. Of course, that's not possible anyway. So what's your thought in terms of how do we maintain that balance in a way that we are still maintaining the energy that's needed locally, and at the same time also having some reserves to be able to help the production of green hydrogen or other alternative derivatives that will be helpful in boosting the economy, but at the same time, we're not starving the local use of the energy. Let me hear your thoughts on that, please.
Yeah, I mean, for us, definitely, if we are talking about green hydrogen projects, it's usually a combination of the energy production and the hydrogen production. So this is a very good point you're raising. We don't want to take grid electricity away from somebody because they would need to replace it then perhaps with gas power or diesel generators. And this would defy a little bit the purpose of producing green hydrogen. So we would always aim to build additional power infrastructure, wind power plants and PV power plants, which actually then could in the same time support the grid, especially when you go to very high renewable energy penetrations in the grid. An electrolyzer can become act in the future in a stabilizing way. On the one hand, reducing a little bit the load when there's less wind and solar, or maybe, as you mentioned, in future scenarios, even using the hydrogen again to support the grid. I mean, immediately we probably see more green hydrogen going into the chemical industry or being exported, but there are interesting scenarios where then you use a bit of this hydrogen to stabilize the grid, especially when you're struggling in certain parts of the grid with blackouts or something similar.
Thank you very much, John George. I think you've really mentioned it rightly. It's not taking away, it's even adding, because in a way, for instance, if we, let's say companies coming in to integrate any of the green hydrogen or green energy, green hydrogen derivatives, factory or industrial production site in there, of course, they're coming to generate. They're not going to just come and hang on the grid. They're going to have their own generation plant or a means of generating. Of course, they may also take from the grid, but whatever they're taking from the grid can be a preservative where that can be fed back at the later part of the day when those grids are heavily used. For instance, in some of the grids, during the night when people are sleeping, it's less used, and those energy are being wasted. So if we use the option of, let's say, hydrogen to store this excess, what I call excess power, and in the daytime when it's super used, all these are fed back again to the grid, I think that would be a very good option where we can maintain that grid on a unified usage approach where in the night we can balance it up with whatever we have by storing in the night and then reusing in the day. That will really be a helpful alternative as well. Let me now come to you, Jensu. Dr. Jensu. Let's look at the area again, another very, very important area to the African storage. I know even in Europe now, storage is still a challenge because people believe hydrogen is very volatile. You have limitations as to where you can store it, but I know ammonia is an alternative in terms of storage. But again, when you crack it back again to hydrogen, a lot of loss and other things. So let me now look at the aspect of storage. I know it's a very, very challenging area at the moment. No standardized storage system has been developed. How has it been in the Asia region? I've been reading on the news how Asia have actually developed several storage systems that have been helpful. Of course, they need to be standardized and all taken to the systems. So let's hear your view. How has it been with the area of storage technology in the Asia region?
Okay. Hello, can you hear me?
Yeah, we can hear you.
Okay, great. So for the hydrogen storage, it's honestly, currently it's really not so easy to do it because the cost is really high currently. So according to our internally understanding, and also we are also doing some study to research on how to utilize the hydrogen after we generated it. So by now, we still think that just make it into transfer to ammonia, and then do the transport and all the storage, and then change back to hydrogen and to use it is the best solution until now. Yeah.
Thank you very much. I think that view is quite clear. So if I were to add to that view, then if we can store for export, then as Africans, why don't we consider a technology that will be able to produce locally, use locally, then you remove storage from the supply chain for now, pending when the technology for storage comes into place. So if you're an African there listening to us now, consider what can you develop locally, use it locally, you remove storage for now, pending when we're able to get a more standardized storage systems. Having said that, let's now go into the area of the transportation side of things. But before then, for those who are listening, please, if you have any question, feel free to post it on the chat section so that we can look at those questions. But let me just come to this question. And there's one question here, and it says, maybe I will direct this to any of the panelists can just answer it if you have the answer there. How do we move to get the technology appreciated in Africa to allow the development of the market that attracts the necessary funding to get hydrogen project off the ground? Just to put it in a summarized way, it's like in Africa, how do you really develop a technology that can be recognized and you're able to have an off-taker to buy into that, your technology? Maybe let's start from, maybe Matthias, you can just come in there. I know you've been in Africa, so would you have a view on that, for an African technology just developed, how will they get an off-taker that will buy into that technology?
I think what's important is to make it economically attractive for the off-taker. You're absolutely right. I recently read a quote from the CEO of Bank of America in the Wall Street Journal talking about decarbonization, and he said, if there is a revenue stream, the funding is infinite. And I think that explains the point, right? It's the same as when natural gas got into European market. It's decades ago, but the same story. The thought was always, how do you get that new energy source cost competitive for the end user? What do you need to do? And that's the incentive scheme. So I think you already gave the answer. You have to think it from the end consumer. How do I make it attractive for the end consumer to use the product I want to push on the market? And interestingly, in Europe and in Germany, we always keep the impression that we've thought this through and so on and so forth. But up until, let's say, maybe 1 or 2 years ago, when I sat on panels with with politicians in Germany, it was always thinking from the production side. We always basically, hydrogen was the waste of the energy sector that got dumped into the natural gas grid until they found, and everyone thought, well, that's not attractive. We're not making any money of it, and the projects didn't come. And now we're starting to look at, well, as you exactly pointed out, what could make it attractive for an off-taker, and all of a sudden you create this pull effect of the entire value chain forming up, because suddenly there's the revenue stream I quoted.
Thank you very much, Matthias. I think you've rightly mentioned it. I mean, as an off-taker, if I'm an off-taker, for instance, if you develop a technology that actually attract my attention, I'm going to put my money on it anyway. And that's what, off-takers are investors. They have the money. They're only looking for the technology. So I think for those listening, if you have any idea, any innovations, just go ahead. I mean, develop your concept, put it out, because if your technology attracts the investors, they will put their money into that very technology, definitely, for sure. So yours is to make sure you don't consider yourself as the end user, consider the end users. What would they want? What would they like to see? Look at Africa as a concept, for instance. Don't think of Europe for now, think of Africa. What will be useful to an African when it comes to this green technology? If you go for that, I can tell you, you will get an off-taker who will buy into that technology instantly. Of course, in Africa, we know subsidy is not very much available. And then you have to think of a commercial, in terms of commercially and economically feasible innovation. So if you develop an innovation that is not economically or commercially feasible, of course, that would deter the investors. So that's very important, to note. That will not take me to the next aspect in terms of transportation. Maybe I'll throw this question to you, Jan George. Recently, I saw one of the innovators in Africa. They sent an approach to us, for instance, asking, they're developing a car technology that uses hydrogen. But I was like, if this person could have been very much thoughtful, I think the market which they're focused on at the moment is, an area that will be more, for this, let's put it this way, there are some loss risks when it comes to Africa, for instance, yeah? So you can be developing hydrogen now for instance, a luxury car use. As an investor, that wouldn't catch the attention of the investors. But for instance, if you develop it for a haulage use, those heavy trucks that we know the electric part cannot fulfill that demand, which means there's a void in terms of demand. Let me now put it to you. How is it going? For instance, what can you share with us from what Germany have done in terms of the technology for the transportation sector? For instance, the heavy duty, trucks, those shipping industry that are what I call heavy users, that even the electric aspect cannot fulfill that demand, but the demand is already there, that maybe an African listening now is okay, I can think of that, But for, let's say, a small car, luxury cars, I can tell you it won't be lucrative to anybody who really want to invest. Let me hear your view how it has been in Germany for haulage, vehicles or heavy usage in terms of shipping industry and all those high users. Let's hear your view on that, please.
So I have to speak for United Arab Emirates in this regard. We are developing in Abu Dhabi a sustainable aviation fuel project. So it is kind of a derivative from hydrogen for the mobility sector for airplanes. And I think this is one of the, let's say, easier examples where hydrogen, at least for long-haul flights, will be very difficult to realize. I mean, especially when you consider 40-year lifetimes for airplanes. So having, for example, an e-fuel project with hydrogen could be an interesting avenue. Then you brought up also for the shipping sector. I mean, there will be also probably applications for derivatives again. I mean, people are looking into synthetic methanol or ammonia. And then, as you rightfully said, for heavy trucks there, probably direct use of hydrogen could be interesting. We are planning to test some hydrogen buses in our demonstrator plant in Master City. And we don't have a big mining industry, but there it could be quite interesting, probably, especially in Africa, where this is a big industry, to look into producing hydrogen for these mines, for example. As you mentioned rightfully, for the personal, for the small cars, it probably it has to be seen. But at the moment, there is a very strong competition with electric batteries, and it's not necessary to go to hydrogen there.
Thank you very much, Jan. And apology, I thought you were in Germany, but that's fine. Okay. Yeah, I think you rightly mentioned it, which is correct. I mean, if you know, and I remember the last speaker mentioned something. You want to look for an area where hydrogen will be competitive, because you know when you talk of small cars, hydrogen can never be competitive because electric is more competitive in there. But when you talk of high haulage vehicles, for instance, of course, hydrogen is more competitive. So for investors that are listening now, think of areas where hydrogen is competitive in Africa, and then you'll be able to have a leverage that can really attract investors to, you know, to be able to invest into your technology. Now, let me now move to Genzu, Dr. Genzu. Let's look at another very useful area in terms of the local application. Now, I remember the last, speaker. He mentioned an area that really would be very, very helpful in, you know, in looking at this. He said, look, the fertilizer industry area, the urea, which are locally used, area that may be of consideration when it comes to hydrogen investment. Okay. Now, in Africa, for instance, I was involved in some couple of discussions recently where they are looking at fertilizer. At the moment, an average, Africans who are, majorly farmers, and they are struggling in terms of fertilizers. At the moment, they have to import the fertilizers. These fertilizers will not come in country on time. And when they eventually comes in, it's very expensive because of, duties and all the, currency, conversion and everything that's actually accumulates in it. So at the end of the day, they are paying a heavy amount on those fertilizers than they could have paid, ideally as farmers. Now, for let's say, a company out there today that's listening and say, oh, why can't I consider hydrogen for manufacturing of urea, which is a byproduct of, a derivative, or considering hydrogen for manufacturing of fertilizers, which can be used locally, which means you remove the supply chain of, technology that has to be imported, and also you're able to reach the farmers on time. You meet their demand on time, and I tell you, the farmers will be very happy about that to pay whatever the amount that is needed. Now, maybe you can share your experience in this area. How really will an African, for example, be thinking now in terms of the technology for those derivatives? What's your experience in terms of the Asia regions? Has there been anything in this regard where people are looking at the derivatives? How can they really apply hydrogen to the derivatives in terms of the technology? I don't know if my question is clear enough. So we're looking at the application now in terms of local use for fertilizers, for urea, or other items that are used locally. So what would be your advice to an average African now that's listening that really want to look for a technology that would really meet that local demand for fertilizers and for locally used derivatives?
Okay, so according to my understanding, in fact, if you in Africa, so is there some good scenarios can be used with hydrogen? Is that so? We can consider about to combine the renewable energy such as PV, solar energy, plant together with the hydrogen generator together, and then it will be the good choice. So currently we are also, because as you know that Longi we already have well done on the PV part. So we are also developing the solutions to combine these two together. And currently in China mainland, we already cooperate with one important customer to do this kind of things, to combine the solar and also the hydrogen generator together. And this can, I believe that this kind of solution also can help, really helpful in Africa. Yeah.
Thank you very much for that view. Maybe Matthias, do you want to throw in your view on that as well? I know you've been in Africa. The hanging fruits now is what we're looking at. How really, what would be your advice to companies that are listening right now and they're saying, oh, want to consider technology for the local applications, what we call the hanging fruits? What would be your advice to them?
I think the lessons learned from the projects that we've had so far are quite clear. It's you start again at the total cost for the consumer, and you think, well, where can we find an edge if we want to do something new? I give you an example of a project that we've had in Germany that might also apply to the African context. So first, a bit of physical and technical background. Hydrogen, as many of you know, probably has a very low volumetric energy density because it has a low density. So if you transport hydrogen in gaseous form, you can only transport very little energy. As an example, if you look at the largest hydrogen trucks out there, the 18-meter tube trailers, they transport only half the amount of energy of a conventional oil truck. And that means hydrogen gets quite expensive. And we've had projects that we are currently working on. One is actually going into operation later this year, where the operator and the owner, the company, is making use of that fact. One of the projects is located in a part of Germany where there's not much industry around. So then there's hydrogen off-takers already that need it for the industrial processes and so on. And they would have to pay for gray hydrogen to be trucked in, which gets very expensive. And in the end, it's cheaper to produce green on site. Imagine that. And people are always talking about subsidies, but in the end, this works by just thinking of a clever niche. You know, it's transport, and it's production, transport, and use. And that gives you the cost of hydrogen. Or another example, if I'm not mistaken, is that ammonia and fertilizers are often imported in many African countries. And what you can do is, if you have available natural resources in terms of renewable energies, you can produce ammonia, you can produce the finished product yourselves in the country, and then you can see, well, is that cost competitive to the world market or is it not? And with all of a sudden, with the spike in natural gas prices, green against gray ammonia or fertilizers may become cost competitive with local production and increasing your local value added that we talked about in an earlier question. So I think it's always having the entire value chain in your mind. That's always when clients come to us developing a project, it's always we look at the entire value chain, and then we see where can you intelligently pick your spot with your consumers to actually create value for both parties.
Thank you very much, Matthias. I think you've really made a very good point there. You know, recently we had the opportunity of working with a team of experts looking at the cost analysis in terms of fertilizer importation compared to locally produced fertilizers. And I can tell you it shows very positive. In short, there's a project now ongoing in Kenya that's already looking at this to establish a fertilizer plant where fertilizer is going to be manufactured locally. But the driver is that they have the energy production from the grid, which is at a very, very relatively moderate price, because most of it, so again, energy is the driver there. So if you are located in an environment where the cost per kilowatt of the energy cost is low, definitely it can be an opportunity for you. So if you're a listener out there, you look at, okay, what's the cost in terms of energy unit per kilowatt? And then you can do some calculations, and at the end of the day, it may be more cost competitive to manufacture locally because you have the local resources, everything in there, than even as importing these fertilizers into those regions. So thank you very much for that insight. Then let me now go to the last, the last aspect, because we're running out of time at the moment. But before then, let me see if I can take one question from the audience. But for those listening in the audience, please put in your questions, and our panelists will be more than happy to look at your questions. One of the questions here says, what is the framework for using hydrogen to boost utility efficiency, especially in Nigeria? Maybe Jane George, you can be able to answer this. I mean, how can we use hydrogen to boost our utilities in terms of grid supplies? I mean, we've already spoken about a little bit about that already, where they can store in the night when it's low usage and repack it. But let me hear your view on that then, Jane.
I mean, I can't speak for Nigeria, but what we currently, for example, imagine is also demand response. So we will be building renewable energy plants which supply electricity, which we most of the time would consume ourselves. But it could be an interesting scenario where you're actually working together with utilities and tell them, look, you have a direct wire to us, and if you have problems with electricity supply, we shut down our production and feed into the grid. So there will be, not only in terms of storage, but also just as a demand response, being a big consumer of electricity, which can actually ramp down really fast. There could be some interesting scenarios. I mean, this is still, there is still no working concept or none I know about, but there will be definitely some potential synergies when you integrate these really large consumers into a national grid.
Absolutely, you're very correct in that. But for those listening, it's a very simple logic in there, and it's very just find out from the grid or whoever the utility managers of your country in Africa, and then look at how to really work relatively with them. All you need to do is, if you can be able to, they are producing in the night anyway when people are sleeping. If they're able to store there with hydrogen or any of the options, and then feedback to the system, that can help boost and stabilize those power. And for countries as well that are having challenges in terms of epileptic powers in the day and in the night, that can also be an option to boost such power. So hydrogen, it's an option for boosting the utilities, especially in terms of storage and refilling back again. And even in the telecom as well, if you have your systems where the telecoms, for instance, need a continuous power usage, of course, hydrogen can be used to boost such power as well. Now, let me now look at the application aspect. Recently, I've seen a lot of, I've been opportunity to read a lot of publications on different innovations coming up, for hydrogen. And sometimes it could be a bit daunting, to be precise. Sometimes I pick this and the next one, another one come again. So you're like, which one do I go for here? For Africa, of course, there has not been really much, which makes it a very good playground for any African listening now who really want to think of investing into technology in Africa. Let me start maybe Chenzu, Dr. Chenzu. What do you think in terms of the technology side? What will you think? Let's look at the solar part, for instance, and we can try to narrow it down to the hydrogen part. The rate at which the technology is evolving, how do you think we can, what's your advice in terms of standardizing, because if you pick a technology today and the next day you pick the next one, you will never come to a point. So how do we then come to a point where we can say, we need to standardize here? So what's your experience with your company in terms of your product? You pick a product, you develop it, you standardize it. So let's just hear from you, share your experience on that, please.
So you mean that such as the technology, how to choose the competitive, the standard product, or how to choose the suitable technology to which is more suitable for the such as Africa scenario. So based on my understanding, so so currently we think that is the large productivity ability for the equipment is really important, and also if you can combine your equipment together with some green energy systems, will be more perfect. So that's why. So we are firstly we focus on the solar, and then now we expand to the energy part, and we choose alkaline technology, which is have the competitive cost and a very large hydrogen productivity technology. Yeah.
Thank you very much. I think that's a very good view as well. On that, standardization can be a bit a challenge, especially when it's still evolving. But I believe at some point it will be an area where each of the organizations or the different regions will start to align and standardize in terms of the product. Of course, when we know what happened in the oil and gas, it was the same thing with so many technology back and forward, but at some point, each of the organizations started standardizing, which is a good thing. Let me now move to you now, Matthias. Let me pose this question to you. There's one question online here, and it says, are there any plans to use green hydrogen in refineries? Do you what's your experience with refineries or maybe manufacturing plants or what I may call process plants that have been using, green hydrogen? You're muted, Matthias.
I'm learning. Noticed
No
it
problem.
myself.
We're in the same boat.
Yeah. So I think that's a great place to start. And we heard earlier in the presentation, hydrogen is at its most valuable when it's more than its calorific value. And we shouldn't forget that we are producing a lot of hydrogen today already. We are producing around 70 million tons per year. And that is a market of around $100 billion a year. So we use a lot of hydrogen and produce it. And that comes with quite a carbon footprint that is more or less the same size as the entire carbon footprint of Germany. So I think that's a good place to start, because it's a natural, starting point, and the prices are usually higher than if you just burn the thing. And so from our side, we have quite a few projects in refineries going on for exactly the same reason, that they need to decarbonize first the hydrogen they already use before going to the even more exciting projects that Jan-Georg is mentioning, where you make the entire fuel carbon neutral, not just the hydrogen you use in the refinery. For example, there is a 10 megawatt PEM electrolysis in the Heide refinery in Germany. It's currently the largest operational PEM electrolysis in the world, which it won't be for long, I'm very sure. But I think the chemical industry, you can read, chemical and oil and gas industry, you can read announcements almost every day now. Yara, the fertilizer company, Covestro in Germany, signing a MOU with Fortescue Future Industries. That's just in the last week. And so there's a lot going on, and it's a good starting point. And therefore, I like the question. I totally agree that there's a lot going on in the sector.
Yeah, we're running out of time, but I will just try to see if we can answer this last question, and then we can wrap up. There's a question here. Maybe I will ask Jan-Georg to please provide that. Are there any organization funding research? Of course, I know we can't really channel to Africa because Africa does not have any subsidy, unfortunately. But yeah, there are global funding. But let me hear your view, Jan-Georg, please.
Yeah, I think there's a lot of research going on, I mean, I'm not super aware of which companies or which governmental entities provide funding there, but I think it is very crucial. There will be a lot of domains where progress is needed. It's not only the electrolyzer, which is the most prominent part of it, but it will be going into handling hydrogen. Storage is a really big topic. Then all the downstream infrastructure, the consumers. So there will be a lot of opportunity to advance this whole space. And we just hope that the more the industry is scaling up, the more funding will be also available to get a little bit more into the detail of specific applications.
Yeah, thank you very much for that. But whoever has asked that question, in terms of funding, there are a lot of fundings available, but again, not specific. I mean, some are actually kind of channeled to Africa, depending on the area of research you want to go into. But you could check and be able to, if you also have any challenge, you can get across to any of our panelists. We'll be able to support you in that. But however, there are research funding depending on what you want to cover in your research, and also how important or how valuable will it be to the development of the value chain aspect you want to focus on. So it's something that you need to look into. Finally, before we drop off, I want to just take your last remark from each of the presenters. Maybe I'll start from you, Chenzu. What's your remark to an African thinking of technology for maybe solar or the green energy or the hydrogen energy space?
Again, I think so because the renewable energy resources in Africa is really abundant. So I believe that the green renewable energy such as solar plus the green hydrogen was the best choice for Africa.
Thank you for that remark. That's good. Matthias, let's hear from you, your remark to an average African thinking of technology for the green space.
That's a broad question. I think we as humanity have set ourselves the goal to change our entire world in the next 2.5 decades. And that's opportunity for everyone. You still need to be clever. Not everything will make you money, but there's a lot of opportunity out there in the next 2.5 decades to come.
Thank you very much, Matthias. And Jan George, what's your remark for our listeners?
Yeah, I would also go in this direction. Again, the landscape will change completely. Like the standard or the traditional energy providers will eventually run out or stop delivering oil and gas, and there will be new players coming into the game. And now it really depends on the availability of good renewable resources with a high capacity factor, wind, solar, hydropower. So and eventually, let's say the technical details will be leveled out in the next years, and then it really comes down to do you have good resources? And I think Africa is in a really good position there, and also could be a really big, large consumer for these locally produced hydrogen products and derivatives.
Thank you very much. I think to wrap it up, as our panelists have actually summed it up already. The resources is there, but however, the technology is 1,000 miles. Let me use that word to quantify it. But 1,000 miles start with just one step. So take the step. Think of what can you do for Africa in terms of technology. Don't be afraid to fail. You could fail, that's fine. Fail and then try again. So for listeners out there who are thinking of technology for Africa, the opportunities is great for you, but you need to take a step at a time, seek for guidance, and just the opportunity is great. So thank you very much, everyone, for listening, and I wish you all the best. Thank you.
Thank you. It's been great talking to you.
Thank you
very much.
Thank you.
Thank you very much, Innocent, and thanks to your panelists for this lively discussion. Personal takeaway in the same line as several things that were mentioned yesterday already is that there could be a lot of opportunities for local production, local use. I mean, we mentioned the ammonia, we mentioned the fertilizer, and I know there are several African entrepreneurs listening today, judging by the conversations on the chat and the questions that have been submitted. So yes, it seems that there is an interesting business opportunity there, definitely worth investigating further.